All right, this is the last things we left last time. So I hope everyone is well and in health condition. So we did only the first one, express f in the standard form, but we will again do it again fast, and we will find the vertex, xy intercept, sketch f, find the maximum and minimum value, and also we will find the range and the domain for the function. So let me start from the first one, but after like 1 minute until I see all the students showing up. So what's the first one? Okay, let me start from the first one. What is the first one? We left it from last time. What's the answer for the first one? The standard form for f of x. What's the standard form for f of x? Who will give me the answer for the first one? So this is the quadratic function, okay? But what's the standard for this one? Anyone has the answer from last time? It's 2 times x minus 3. Thank you, Kate. Thank you, Taylor. To the power 2 minus 5. Okay, how we get this one? So again, let me do it again and explain it again. So the function is f of x equal 2x squared minus 12x plus 13. So the standard form, first things, we're starting from these two coefficient terms, such that we make the coefficients for x squared equal 1. That means we have to factor by taking 2 outside, then the left is 2 is x squared, sorry, minus 6x plus 13. This is the first step. Second step, we try to complete the square for these things. What's the completing the square? By adding b over 2 square. But because we add b over 2 square, we have to remove it by b over 2 square again. So we add b over 2, all of these square, minus b over 2, all of these square. What is b? This is b. The number 6 is b. So what we have? 2 times x squared minus 6x plus b over 2. 6 over 2 squared, it's 9. So we add 9, and we subtract 9. So we add 9 and we subtract 9. So what we are doing here, why we add and subtract? This is mean we're adding 0. This is mean we don't affect in the parentheses. Like we adding something, we subtracting the things. This means like we're adding 0, exactly. Like we don't change anything. So by adding 9, subtracting 9 plus the 13. This is the left here, going down, okay? So again, we do the completing the square for this one. I mean, like we factor this one. Okay, how we factor it? It's by 2 times x minus 3, everything square, and the left 9, minus 9, go down again, plus 13. Now, we distribute the 2 for the both of the terms. So I get 2 times x minus 3, everything square, minus 2 times 9 times 2 plus 13. Now the answer is 2x minus 3 square minus 18 plus 13 is minus 5. So this is the standard form. Any question? All right, so let's go to the second part. So this is the standard form for the function. Now from the standard form, we have to find the second part of the question is finding the vertex and find x and y intercept. So from last time, I said the vertex, it is, if I have the standard form look like this, f of x equal a times x minus h plus k. So the vertex is, from last time, is the point h and k. So going back to my answer, the standard form here, going back to my standard form, f of x equal 2 times x minus 3, everything square, minus 5. So this is, the 3 is h, and the minus 5 is k. So the 3 is h. So the vertex is the 3 and minus 5. Any question? Okay. Third part of the question is asking about the x, y intercept. X and y intercept. So from the chapter, I think 1 or 2, the x-intercept by setting y equals 0. And again, the y-intercept by setting x equals 0. This is the 2 notes from previous chapter. So now the question is asking about the y-intercept. So the y-intercept by setting x equals 0. So we plug the 0 inside the function. So the y now intercept for my question is f of 0. So f of 0 is equal 2 times 0 square minus 12 times 0 plus 13. So the answer is 13. F of 0 is equal 13. And a question for y-intercept. Perfect. Now for x-intercept, by setting y equals 0 or f of x equals 0, f of x now equals 0. So when f of x equals 0, I can use the standard form, this one, because this is the same as here, the same as the quadratic function, f of x equal 2x squared minus 12x plus 13. This function is exactly the same like this one. So I can use this one, or I can use this one to find the x-intercept by making f of x equal 0. So now make f of x equal 0. So I'm going to the next slide. So f of x now, f of x equals 0. So by using the standard form, I know the standard form is f of x equal 2 times x minus 3 squared minus 5. Okay, so making f of x equal 0, this is equal 0, equal 2x minus 3 squared minus 5. Now I solve this one. I solve the equation by adding 5 for both sides. So I get 5 equal 2x minus 3 squared. Now I divided by 2 for both sides. So I get 5 over 2. So I get 5 over 2 equal x minus 3 squared. Now I take the square root for both sides. Taking the square root, taking the square root. So I get x minus 3 equal positive negative square root of 5 over 2. Now I add 3 for both sides. So the final answer is x, I'll write it here, x equal 3 plus negative square root of 5 over 2. This is the x-intercept. So we find the x-intercept, we find the y-intercept, we find the standard form. Now let me go to the third part. Is it clear for all before moving? Any question? Okay. Now let's go to the third part, sketch F. Number 3, sketch F. So we find the vertex, we find x and y intercept, and we find also the standard form from 1 and 2, we can sketch the function f. Let me show you how we can sketch the function f. So number 3 now. So third part, sketch. So to sketch the graph, we have the x-intercept and y-intercept, and we have the vertex. And last time, like I said last time, any quadratic function, it's look like parabola. Parabola means the function look like this, like that. If a is positive, ax square, if a is positive, or look like this, if a is negative. This is ax square. So the graph for this function, the function f of x equal x square equal 2x square 2x square minus 12x plus 13, it's look like parabola exactly, look like the red one, like this or like that. But how we graph it? By using the first part of the question and the second part of the question. Since I have the vertex I find it from the first part. The vertex was let me go back to define the vertex. The vertex was 3 and minus 5. This is the vertex. It was here 3 and minus 5. This is mean here the vertex. If we look into the graph here to the parabola, to this parabola or to this parabola, the vertex is in the here in the bottom, but here is in the top. This is the vertex. So the vertex here I have is 3 and minus 5. So this is a 3 and minus 5. This is the point is 3 and minus 5. This is the first thing. The point 3 and minus 5. So now A here in this graph, by going to the standard form again, like I told you, to graph this function, we have to know the standard form and we have to know the vertex and x and y intercept. So the standard form, if we go back to the standard form, see. So if we go back to the standard form, this is the standard form. This is the standard form. A here is 2. A is equal to, so it's positive. And from last time I said to graph the function, we look into the A. We look into the A. So the standard form A is equal to from the standard form, and this is positive. And if it's positive, that's mean the parabola has a shape upward. Upward, that's mean it's look like that. So upward. So I find the vertex. This is the vertex from the graph. And the shape, because A from the standard form is positive, so it look like upward to the up. And this is the graph for this quadratic function. But if we want to add more points, so I know the x-intercept, this is the point x-intercept. It's 3 plus the square root of 5 over 2. And this is 3 minus the square root 5 over 2. From where I get this one? From here. This is the x-intercept. So the graph intersect the x-axis and the point 3 plus 5 over 2, square root of 5 over 2, and also the minus 3 minus the square root of 5 over 2. And also the y-intercept, it's here. This is the y-intercept. I find it from the second slide. So the y-intercept, it's 13. f of 0 is 13. So again, this point is 13, 0 and 13. So from the y-intercept, x-intercept, and the standard form, and the vertex, 4 things, I can graph the quadratic function. Any question?
I have a question.
Yeah, what's your question?
How did you figure out where 3 minus 5/2 was?
Is 3, 5/2. This is the x-intercept. If we go back to the x-intercept by setting y equals 0, look, or f of x equals 0, and we solve the equation by here, 0 equal 2 times x minus 3 square minus 5. We add 5 for both sides. So we get x equal in the top here, equal 3 plus or minus the square of 5/2. So the first point is 3 plus square root 5/2. And the second point is 3 minus square root 5/2. So this is here, if we look into the graph, this is point here is 3 plus square root of 5/2. And here, this is the point is 3 minus the square root of 5/2. I answer your question? Perfect. So, and this is like review from like previous chapter, I think chapter 1 or 2 for x-intercept and the y-intercept. Just like go back to the section x-intercept and y-intercept and review it. So again, we need the vertex, we need the x and y intercept, and we need the standard form. This is first point, second point, and the third point, standard form. Standard form. Now let's go to the, any question? Okay, let's go to now to the fourth part here, number 4. Find the maximum and minimum value. So again, to find the maximum and minimum value, like I said last time, if you go to your notes from last time, from the standard form, I can find the maximum and minimum value. So my standard form in this equation, f of x equal 2 times x minus 3 squared minus 5. So from last time I said, if a, to find the maximum and minimum value, if a is positive, then f of x has minimum value is k. And second things, if a less than 0, f of x has max value is k. This is k, and this is h. So here, a, and this is a. This is a here. This is a. The number 2 is a. So this is a. This is h. This is k. So from my question, a is equal to. That's mean is positive. That's mean f of x has minimum value. What is it? Is k. It's minus 5. So this is the answer for my question. A equal 2 is positive. That means f of x has minimum value is minus 5. And the minus 5 is the minimum value. Or I can say the elements, the vertex. What's the vertex? I know the vertex is 3 and minus 5. This point is the minimum value. Again, the vertex is H and K. Any question? If the element A is less than 0, so it's negative, that means f of x has a maximum value. But here in my question, A is 2. That means it's positive, is greater than 0.
No, I know that. I wanted to know that if it was less than 0, would the maximum be h?
Again, what's your question? Can you repeat it?
If a was less than 0, would the maximum then be h, or would it still be the k?
It will be K, not H. It will be K, not H. The point 3 and minus 5, the point, everything. See the point? Everything is called the minimum value. Or I can say the minimum value is minus 5. That's it. Yeah, both of them are equal to K, but which is choosing K, which is choosing the minimum or the maximum is A. If A is positive, then K is the minimum. If A is negative, then K is the maximum. Both of them are K, yes. Both of them are K, not H. Who choose K is positive or it's minimum or maximum? The value for A. So first of things, I have to check what is A? What's the sign of A? It is positive or negative? If it's positive, then K is maximum, or if it's positive, then K is minimum. If it's A is negative, then K is maximum. I answered your question, Marilyn?
Yeah.
Okay. Taylor, I answered your question?
Yes.
Perfect. Anyone has a question before we go to the last part of the question for the example? Okay. So let's go to the last part of the example is number 5. Find the range and the domain. Okay, this is review question. So from the graph, if we're going back to the graph, this is the graph for the function. Here, this is the graph for the function, the quadratic function. So from the graph, I can find the domain. What is the domain? This is review question. The domain here, I can plug down negative. Look, the domain here, if we look into the x, all this value are inside the domain. That's mean the domain is R. And for the range, just starting from this point, from the vertex, from here, and everything up. So the range will be like from -5 to infinity. So the graph for number 5, the graph looked like this. This is the vertex here. It's 3 and -5. So again, the domain from the graph is everything. Look to the x. All the value in x are using. So that's mean the domain is R. And if we look into the y, just starting from this point here, this point is -5, and everything up is using, because here it has value, 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 everything has a value. So the range is from -5 to infinity. Any question? The -5 is inside. Sorry, the -5 is inside the range because it has value. Any question? What's your question, Kate? Okay, sure. So for the domain, again, let me make not, it depends. So for the parabola in general, if it doesn't give me a condition, all the parabola, the domain is R, but without condition. Without condition, I mean, if the function doesn't have like certain value, doesn't give me a certain between 2 points. But if I give, like, the question is, give me in general, what's the domain for like for any polynomial function, always any polynomial function without giving any condition, the domain is R. The polynomial function always the polynomial function always has a domain R without condition. Without condition, I mean, if I give you, for example, f of x equal x cubed, what is the domain? Is R. But if I give you, for example, f of x equal x cubed, such that x between 2.2 and -2 would equal here. So the domain here is the enclosed interval -2, -2, and 2. So with a condition is different about without condition. Without condition is always R. So here the domain is R. The domain here is the closed interval. So the quadratic equation, is, it is a polynomial. It's a polynomial function. F of x equal x squared, it's a polynomial function. Or f of x equal, for example, x squared plus 4x. This is polynomial, so it's the domain is R without giving condition. Domain is R. I answered your question, Kate? Yes, Marilyn. R, it's the real number. It's all real number. Perfect. R, it's the natural number and integer number and rational number and irrational number. All these are called R, real number. This is from chapter 1. Okay, so now let's go to any question before we moving to the next topic. Good. So now let's go to something new. How to find the maximum and minimum value without using the standard form. Standard form. So for example, I give you like quadratic question, give you quadratic function, and I ask you for the maximum and minimum value without doing the standard form to find it. So this is the way, this is the definition. To find maximum and minimum value for the quadratic function, for example, f of x equal ax squared plus bx plus c, by finding first things x that's equal minus b over 2a. So this is the first step. I go to find x. I said, what is x? X is an element minus b over 2a. This is b and this is a. This is b and this is a. Second step, we check the value for a again. If a is positive, then f of x has minimum value, is f of minus b over 2a. Of this point, actually. Here 2a. And if a is less than 0, that's mean negative, then f of x has maximum value. What is the maximum value here? Is f of the same point, minus b over 2a. So I have to check what is the value for a. A is positive or is negative? If it's positive, then f of x has a minimum value. Is f of this point here. If it's negative, then the f of x has a maximum value. Is this point, the same point. So it depends in a. So we have to focus in a. We have to check the value for a. So I give example for that. Can I move to next slide? Okay. So next one. So example, find the maximum and minimum value for each of the function without using the standard form. So equal, so f of x equal x squared plus 4x. This is the first one. Second one, b f of x equal minus 2x squared plus 4x minus 5. So I give you 1 minute or 2 minutes to find the maximum and minimum value for both of a and b, for both of the two functions. Second function, I will change the name to the g of x. First function is f of x. I give you 2 minutes by using this rule to find the maximum and minimum value. This is the function again. So for the first one, a, to find the maximum value without the standard form, my function is f of x equal x squared plus 4x. First things, I found the value for x. It's minus b over 2a. This is equal. What is b? This is b. It's the 4, number 4 is. And what is a? It's the number 1 here, the coefficient for x squared. So this is equal minus b minus 4 over 2 times 1. This equal minus 2. Now I have to check. Check what? I have to check a. A is equal 1. This is greater than 0. That's mean the function has minimum value. F of x has minimum value. And its value is f of this element, this number, minus 2, f of minus 2. So for the first one, and if I want to find the f of minus 2, just I plug the minus 2 inside the function. So f of minus 2 equal minus 2 squared plus 4 times minus 2. And they give me 4 plus minus 8. This is minus 4. So the function f of x for the first one has a minimum value, and its value is minus 4. Is it clear? So it depending in the function and the question. If they ask you to find the maximum and minimum value by using the standard form or by using this properties. Second one, for g of x, again, g of x. Again, we find the value for x. What's the value for x is minus b over 2a. And this is equal minus, what is b? This is b, it's number 4. This is b, This is A, this is C. So minus 4 over 2 times minus 2. And this is equal minus 4 over minus 4, and this is equal 1. Now we check A. A is equal minus 2, less than 0. That's mean the function has a maximum value. F g of x has maximum value, and its value is f of 1. Just you plug the 1 inside the function, and you get the answer is minus 3. Again, you plug the 1 here inside the function g of x, this function. So you get minus 3. Any question? Is it clear for all? Okay. For part B again, for the function g of x, first things, like I said before, we have to find the value x. The value x is minus b over 2a. B, the value for b is 4. But because the formula is minus b, so minus 4 over 2 times a. 2 times, what is the value for a? It's minus 2. I'm working this function. The value for a is minus 2. So minus 4 over minus 4 equal 1. Now again, I have to check the value for a. The value for a is minus 2. So minus 2 is less than 0. That's mean the g of x has a maximum value. The maximum value is f of this value, the number, the x, f of 1 is equal minus 3. Is it clear? Okay, perfect. Now let's go to the 3.2, new section. It's called polynomial function and graphs. And their graphs. Did you plug, I get a question, did you plug one into f of x or in g of x, because I'm working in g of x. For the second one, oh yeah, sure. Yeah, g of x here. G of x here, g of 1, because the second function is g and the first function is f. So I plug the 1 inside the g of x is equal minus 3. Thank you. So I'm working in the second one for g of x, the first one is for f of x. So going back to 3.2, polynomial function. Polynomial function. So again, the polynomial function p of x, this is the review from previous section. P of x equal en xn plus an minus 1 x to the n minus 1 plus to the a1x plus a0. So from the polynomial function here, so in this section we will study the polynomial function and how we can graph this function. So in the first section we talk about before we talk about linear function, constant function, like we talk about the constant function, we talk about the linear function, and in section 3.1 we talk about the quadratic function, and in this chapter in this section we'll study the polynomial function, like when n is more than 2, like 3 or 4 or 5 or whatever. So we have some notes here for the polynomial function. First things, this is in the red color, is called coefficients. So A0, A1, A2, 2, AN, all of these are called coefficients, are called second things, the A0, the coefficient A0 is called constant coefficient. Or is called constant term. But AN, the coefficient AN is called leading coefficient. And the term ANX to the N is called leading term. This is some concept, just important concepts. We will use it during this section. So all these are called coefficients. A0, A1, AN minus 1, AN are called coefficients. A0, the first one here, is called constant coefficient or constant term. And AN here is called leading constant, and the term ANXN is called leading term. So I give you example, like small example for using this terms. Example is, for example, 3x to the 4 plus 7x to the 3 plus 12x to the 2 plus 30x plus 15. So 3, 7, and 12, and 13, 30, and 15, all of them are coefficients. Now, the 15, this 15 here, this one, is called constant term. And the 3 here is called leading term. And also 3, x to the 4 is called leading, no, sorry, not leading term, leading coefficient. This is leading term. Also here, and this is called constant coefficient. Has two names, constant coefficient, constant term. The 3 is called leading coefficient. 3x to the 4 is called leading term. Any question? This is just the definition for the concepts. Is it clear for all? Good. Again, what's the degree for this polynomial? The degree here is 4. Exactly. Is the highest power or exponent. So look at the power here. We have 4, we have 3, we have 2, we have 1. Here we have power 0. So we're looking to the highest one, and the highest one is called the degree. So the degree for this polynomial is 4. Okay, so now let's go to the new part of this section is called a graph basics polynomial function. Graph basic polynomial functions. So we know that like the simplest polynomial function, it's look like the simplest polynomial function. It's look like this. B of x equal x to the n. This is the simplest one without any extra term, without anything here, we don't need it. So this is called the simplest polynomial. So also we know how to graph the simplest polynomial. For example, for if n is equal, for example, 1, like f b of x, it's only x. It's a linear function. Look like that. And if n, for example, equal 2, like from previous section, so b of x equal x squared, this is a quadratic function. Look like that. If n equal, for example, 3, it's look like that from section before. Now, if n equal, for example, 4, it's look like similar to x to the 2, but a little bit open. Look, a little bit here. Is close to the 0. Like here, look, this side. And when n equal 5, the same like x, n equal 3, but around the 0, it's like a little bit open, okay? Like that. then we do it. This is p of x equal x to the 5. So from this graphs, n equal 1, n equal 2, n equal 3, and n equal 4, n equal 5, we can see all the function or the polynomial function x to the n, where n is even, like 2, 4, are similar to each other. It's look like the same graph. Look here, n to the 2, and look here, n to the 4. It's look like each other, similar. And also n to the 6, it will be like the same. N to the 8, the same. So all the even power are the same, like that, like cup. And also for n equal 3, all the odd, it's look like that. But the difference around the original point 0, 0, around the original point 0, 0, it's more flatter. I mean like more open. Look here, this is the difference. So I give you this note, b of x equal x to the n. When n is even, looks like this. And p of x equal xn to the n. And is odd, looks like that. Any questions so far? Okay, good. So this is the first point in this section. Now I give you example. Sample. The question is sketch the polynomial b of x. This is the first one. Equal minus x to the 3. Second one, q of x equal x minus 2 to the 4. I give you like 2 minutes to think how we can graph it or sketch this, both of them, and I will solve it. All right, so for the first one, number 1, b of x equal minus x to the 3. So again, n is odd, and here is n equal 3. And like I said before, if n, from the previous slide, if n is odd, all the graph, it's similar to this one. And if n is even, all the graphs look like similar, close to this graph. All right, so let's go to graph the first one. So I know the graph for b of x equal x to the 3, but here we have minus outside. This minus mean we have to reflect this polynomial around the x-axis. So I know how to graph the function. For example, b of x equal x to the 3, like I said before, it's look like that. But here we have the polynomial look like b of x equal minus x to the 3. That means we have to reflect it around the x-axis. We look like that. We reflect it around the x-axis. This is the x-axis. So the graph for the function look like this. This is the x-axis again. So this is the graph for the first one. Now the graph for the second one, number 2, is a q of x equal x minus 2 to the 4. So again here, it's similar to the x to the 4. And again, 4 is even number, and here is 4 equal 4. And the 4 is even number. And like I said before, even number, all the even number look like cups. So here it will be look like cup, but again, because we have minus 2, we have the minus 2, this is mean we have to shift it to the right 2 units from previous sections. So I know how to graph first things. For example, q1, I will change the name for the function, equal x to the 4, for example. It's look like this. This is the graph x to the 4. But because we have minus 2, and the minus 2, it's inside, this means the graph, we have to shift it 2 units to the right. So it will look like that. So this is the graph for q of x. Any questions so far? So here the q star for x to the 4 look like that. And here q of x, the original function. Okay. If anyone has a question before we move to different things. Except Taylor, I mean. Is it clear for all? Perfect. So now, after today, we can sketch any polynomial function. I mean, any polynomial function for any function to the power greater than 2. Look, here is power greater than 2. Here greater than 2 is 4. The power is 4 here. Now let's go to the new things. So I have to go to a graph of the end behavior, using the end behavior. So the end behavior for polynomial. So what's the end behavior? I mean, for end behavior, how is the graph look like when the value for x is getting bigger, like when you get infinity, or going more large number? Or in the opposite way, what's happened to the function when the value for the function is getting smaller, going to the minus infinity, minus element? So from this part, we know how to define the end behavior for the polynomial function. So I give you like a small definition. Let p of x equal, for example, a to the n, x to the n. This is the polynomial function. A to the n minus 1, x to the n plus minus 1, going to the a1x plus a0. So by using two things, by using the degree for the polynomial, the degree n, by using the degree n, and by using second things, the sign for the leading coefficient of leading coefficient, it's an, the sign, like positive or negative, okay? By using these two things, I can determine the end behavior for the polynomial. So let me give you like more explanation. For example, suppose b has odd degree. What is the meaning of odd degree? Like, for example, 3, 5, 7, 9. This is all of these are odd degree. And the leading coefficient is positive, is greater than 0, positive. So the graph will look like this. So the degree is odd and the leading coefficient is positive. So the graph, it's look like that. Look like that. That's mean when x goes to infinity, y goes to infinity. What does that mean? Look to the value for x. This is the value for x. So when x goes to large number, infinity, the value for y, look to the value for y, goes to the infinity. So when x goes to infinity, y goes to infinity. And again, when x goes to the small number, x goes to the minus infinity, then y goes to minus infinity. Look to the graph. Here is the value for minus infinity, the graph. Then the value for the y is going again to the minus infinity. By looking to the graph function, the graph going down, down, down. And in the opposite way, when the value for x is large, the value for y going up, 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 up. So the first case is when b is odd, has an odd degree, and the leading is positive. This is the first case, number 1. Any question for number 1, for the case number 1? Okay, let's go to the next case. Second case. Second case, when the polynomial b of x has, again, odd degree, the degree is, like I said before, the highest power. And the leading coefficient is negative. Leading coefficients, it's an. An is the leading coefficient, and it's negative. So the graph look like that. Something to that. This is mean when the value for x is going to the large number, then y goes to minus infinity from the graph. So again, this is large number, x, and this is the value for y, going down. Same things for here when x going to the small number. So the value for y going to the infinity. So when x goes to the minus infinity, then y goes to infinity from the graph. Is it clear for all? This is the second case. So you have to know what's the degree for the polynomial and what's the sign for the leading coefficients. From two things, I can decide what is the end behavior for the function. Is it clear? Okay, the third case. Here is the third case. Third case. So if the polynomial b has even degree, okay, and the leading coefficient is positive, is greater than 0. So the graph look like that. Like I said before, it's like the x square. It will be like that, going down, up, and then like that. That's mean when the value x going up, getting positive, like greater, like big number, the value for y again going up, going large. So the first one, when x goes to infinity, this means y goes to infinity. And the same things when x goes to the minus infinity, again, by looking to the graph, y goes to infinity. So here, when x goes to minus infinity, and here, when y goes to infinity. Is it clear, the third case? No question? Fourth case. Fourth one. If the b has even degree, again, so I start for odd, even degree, and the leading coefficient is negative. So again, it will look like that. This is mean when x goes to infinity, y goes to minus infinity, and when x goes to minus infinity, y goes to minus infinity. From the graph again, look when x goes getting bigger, y goes to getting like small. Same things here. When x is small, y is small. This is called the end behavior. This is the fourth cases for the end behavior. Any question? Yes, we have to memorize all these 4 cases because I give you example after this, and if you memorize, like, you don't have to memorize it exactly, just you have to know it's even, like by using the degree. If the degree is even and the leading is negative, so it would be like look like I said before, even degree look like the parabola. So the parabola, it's like has a face down because the leading is negative. So that's mean you have like to know when x is going to the up to infinity, this is mean the y goes to the minus infinity. And the same things for when x goes to minus infinity, y goes to the minus infinity. Is it clear? No, you don't have to write like a notation. Just you have to write it like that. When x goes to infinity, how is y? Y goes to infinity or going to the minus infinity. When x going to the minus infinity, what's the value for y? Just I want to know what's the value for y when x going to the infinity, x going to the minus infinity. What's happened to the value y? This is the answer for Jose. Yeah, you can like write it, Taylor. You can draw parabola look like W. You can draw it like that. It must be have a face up or face down. This is the parabola. Parabola can draw it look like that. This is like the simplest parabola. Let me go to the new slide. New slide here. So the simplest parabola, it's b of x equal x squared. It's look like that. We have sometimes polynomial has has an even degree. It's not just look like that. It's look like, for example, like that, up, down, up, down, up, down, up. But the degree for this polynomial, it's even. That's why it's look like the end behavior. If we look into the end behavior here and the end behavior for here, it's look like the x squared. This is just like connection between the even degree. It's look like the polynomial b of x equal x squared. Look to the end behavior for x squared. It's look like the parabola, the polynomial of even degree. But here inside, I don't care. It's look like that. So in general, the even degree, all of them has like being behavior look like similar to the x squared. This is the even. For the odd, all of them are close to the polynomial x to the 3 or the x cube. So now, perfect. Any question for the end behavior? I give you example for the end behavior. So the example, it's come like that. What's the end behavior? What is the end behavior for b of x equal minus 2x to the 4 plus 5x to the 3 plus 4x minus 8? So to find, this is the question, like every final exam, most of the final exams, they ask a question look like that. So this is very important with the end behavior. So first things we have to know, like I said before, the degree. What is the degree for this polynomial? Yeah, what's the degree for this polynomial? Kate, what's the degree? Is 4. Perfect. The degree for this polynomial is 4. Why? This is the highest polynomial. This is the highest degree. This is the highest power. Second things you have to ask yourself, what is the coefficient here? The leading coefficient. The leading coefficient is -2. Perfect. Is -2. So I have degree is even. The degree is even. And the coefficient, the leading is negative. So that's mean it's look like the graph for this one, it's look like that. Or in different way, it's look like that. It's not exactly like that, but it's look like that. Okay? That's mean by looking to the graph, this is from the cases. Go back to the cases, the even and the coefficient is negative. This is the, I think, the third cases or fourth case from before. This is mean the answer for this question look like that, or look like this graph. This means when x goes to infinity, y goes to minus infinity. This is the first thing. Second things, when x going to the minus infinity, from the graph, this is when x goes to minus infinity here, everything here. Like all the elements when x goes to minus infinity, it's look like here, the y goes to minus infinity. And this is the answer for this question. Is it clear? Perfect. Any question? You have to memorize all the cases to answer a question like that. So I give you exercise. I'm not going to solve it, but I give you exercise. Perfect, yes. If you memorize all the cases, case 1, 2, case 3, and you know how to draw, like what's the sketch, so you can know how to solve this question. You know how to, when x goes to infinity, y goes to where? X goes to minus infinity, y goes to where? So I give you exercise. The question is, find the end behavior. I'm not going to solve it. This is for you. For the polynomial b of x equal 3x to the 5 minus 5x to the 3 plus 2x. I give you just hint. The degree here, what's the degree for this polynomial? 5. Yes. Is 5. What's the leading coefficient? It's 3. So the 5 means is odd polynomial, and the leading is a 3, that means is positive. So go back to the cases and you can find the answer. When x goes to infinity, what is y goes to? When x goes to minus infinity, Where is y goes to? From the cases. Okay, so now for the last things for this section, how to graph polynomial function. So we have 10 minutes. I think it's enough to explain how to graph the polynomial function. If we did not finish it, we go back for this part of this section next time. So graph of polynomial function. So after this part of this section, we know how to graph any polynomial function. So the question is, suppose so I will start from example. I will start from example to explain these things. Suppose I have b of x, the polynomial, look like x plus 2, x minus 1, x minus 3. So to graph this polynomial, first things I give you steps again. I know a lot of steps for this chapter. First things we have to know the zeros, 0 for the polynomial. For the polynomial. So what's the 0 for this polynomial? I mean, when bx equals 0, what's the value for x that make b of x equals 0? Is x equal minus 2, or x equal 1, or x equal 3? So this is the three values that make the b of x equal 0. Or we solve the polynomial like before. X plus 2, x minus 1, x minus 3, all of these are equal 0. This is mean this is equal 0, this equals 0, this equals 0. So the answer is x equal 2, x equal 2, x equal 1, x equal 2. This is the first step. You have to find the 0 for all for the polynomial. Second step, you have to draw a horizontal line and put the 0 point on this line. So this is 3, this is 1, this is minus 2. Now we have to find the sign for this, the sign between the minus 2, between minus 1, between 1 and 3, between minus 2 and 1, and the sign here. So we have to find the sign. How we can find the sign? By choosing any element between this interval. For example, I will choose here the 0 and plug this 0 inside the polynomial, inside here. And then the answer, they give me the sign. For example, p of 0 is equal to 0 plus 2, 0 minus 1, 0 minus 3. And this is equal to times minus 1 times minus 3. And the answer is 6. This is mean is positive. So the answer here, the sign here is positive. Again, I choose any element here. Again, for example, I choose 2. And I plug the 2 inside the polynomial, p of 2. So the answer is 2 plus 2, 2 minus 1, and 2 minus 3. So the answer is give me like negative numbers, because it's give me 4 times 1 times minus 1, and the answer is negative, less than 0. So the sign for this interval is negative. The same things here. For all elements between 3 and above, choose any number like 5, 6, 7, 8. Here is negative, sorry. Here is negative. Here is negative. Choose any element, like any number greater than 3, they give me positive value, and they plug it inside the polynomial. And the same things here for less than minus 2. They give me negative numbers. So negative, positive, negative, positive. Now I can graph the polynomial function by using these things. So going to the next slide. This is the graph. Here is minus 2. Here is 1. Here is 3. Here is positive. Here is negative. Here is positive. Here is negative. So the graph look like that. First things, we have to put all the zero number, 3, 1, minus 2. Because less than 2 is 0, is negative, so the graph look like that. Between 2 and 1 is positive, that means it's up. This is up. And between 1 and 3 is negative, so that means the graph going down. And between 3 and above is positive, that means the graph going up. So this is the graph for the polynomial function. Any question? So we'll finish for this section. Any question? Yes, I will go over this one again next time. Yes, next class. So until here, the class is over. So let me stop recording, and thank you everyone.